Kim 107. We are in our third video for chapter 3, and now we're going to talk some chemistry. We're going to talk about chemical reactions. So a chemical reaction is when we write the chemicals that react and turn into products. We separate the reactants from the products with an arrow. So in my little reaction here, I say A plus B chemicals will make C plus D chemicals. Now, A and B are the reactants. They're going to turn into C and D, which are the products. Now, we also, behind each chemical, use a symbol to indicate its state of matter. Parentheses S is for solid, parentheses G is for a gas, and parentheses L is for a liquid. Now, one kind of chemical reaction we've already mentioned, burning things, which is combustion. So we burn fossil fuels, and that's a combustion reaction. So let me show you what a combustion reaction looks like involving a hydrocarbon. Whenever we burn a hydrocarbon, we produce carbon dioxide and steam. Steam is just water in the gas state, right? Steam. Now, to burn something, what do you need to support a flame? I hope you said oxygen, because you're right. In order to have a flame, we need to have oxygen access to it. That's why if you burn something on your stove, you just put the lid on. Then the oxygen can't reach the fire and it will go out and extinguish itself. So if you look at this reaction right here, we have 2 molecules of C2H6, which is a gas, plus 7 molecules of O2 gas, which is oxygen, making the arrow 4 molecules of CO2, carbon dioxide gas, and 6 H2O gas, which is steam, 6 molecules of steam. So you need to recognize something like that as a combustion reaction. So we're going to have our hydrocarbon, a CH chemical, plus O2 gas, because oxygen supports the flame, then the arrow, and we're going to make CO2 and H2O gases. So combustion always looks like that. So oxygen is a reactant that supports the flame, and then we have numbers in front of the chemicals that indicate how many molecules we need for the reaction to be balanced. So let's talk a little more about balancing. So according to the law of conservation of matter, matter cannot be created or destroyed, only conserved. So you need to remember this law of conservation of matter. Matter cannot be created or destroyed. So this means I can't just make things disappear or appear because of the law of conservation of matter. So this means if I start with 4 carbon atoms on the left side of the arrow, I have to end with 4 carbon atoms on the right side of the arrow. So let's look at this reaction. I have Na solid, sodium, plus Cl2 gas makes NaCl solid. So according to that reaction right now, I just have 1 sodium atom, but Cl2 means 2 chlorine atoms bonded together. So there's 2 chlorine atoms, and then the arrow, and then NaCl, and there's just 1 Na and 1 Cl. Uh-oh, the chlorine atoms are not balanced. How can we fix this? I want you to think about it for a minute. So we can only put a number in front. So since we have 2 chlorine atoms on the left side, what can we put in front of NaCl to make 2 chlorine atoms on the right side? I hope you said a 2. You're right. We need to put a 2 in front of NaCl. Then we have 2 Nas and 2 Cls on that side of the arrow, the right side of the arrow. Oh dear, that messes up our Nas. We only have 1 Na on the left side. So what do we need to do there? What number can we put in front of Na? You're correct if you said a 2. Put a 2 in front of Na. So we get this in blue. We get 2 sodium atoms plus Cl2, which means two Cl atoms bonded together, arrow, two NaCls. So we have two sodiums on both sides. We have two Cls on both sides. So we balance the reaction by putting those twos in front. Now, after this video, I'm going to have a couple of short videos for you to learn more about balancing. So you're going to watch those. Let's see if you can balance these right now. You may need to watch those other videos and come back to this. I'm going to let you hit pause and see if you can balance these reactions on your own by putting numbers in front. All right, so I hope you did that. So in the first one, we have a carbon atom, we have two oxygen atoms, we have the arrow, and then we have one carbon and one oxygen atom, so it's not balanced. So this is kind of similar to the one we just did, so I hope you were able to do this one. We need to put a 2 in front of CO. That'll give us two carbons and two oxygens. Then we have two oxygens on both sides. But then we have two carbons, so we have to put a 2 in front of the carbon on the left side as well. So we're going to put a 2 in front of carbon and a 2 in front of carbon monoxide. Okay, let's look at the next one, a little bit harder. H2 gas plus N2 gas makes NH3 gas. Let's look at the N's first. And I'm just picking that randomly. We could look at the H's first. It doesn't matter. We have two N's on the left side. We only have one N on the right side. So what can we put in front of NH3 to make two N's over there? A 2, right? So we're going to put a 2 in front of NH3. Then we have two N's on both sides, balanced. However, that 2 in front of NH3 means there's now 6 hydrogens. 2 times 3 is 6. There's 6 hydrogens. So what needs to go in front of H2 on the left side to give 6 hydrogens on the left side? You're correct if you said a 3. So there's our two reactions balanced. Again, I have a separate video for you to watch to help you with balancing. If you're not getting it right now, don't panic yet. You can watch those two really short balancing videos. Okay, so we're going to only balance easy, simple equations. All right, there are 3 types of reactions I want you to know. They're in this table. Combination reactions. The generic example is A plus B makes AB combined. That's why it's called combination. They combine. You have two things combining into one product. So that's pretty easy. Decomposition. We have ABC arrow breaking down into A plus B plus C. So it's separated. That's called breaking down. Breaking down means decomposing, doesn't it? So that's decomposition. We have one reactant and it breaks down into 2 or 3 products. So that's pretty easy. If it breaks down into pieces, it's decomposition. And then the last one we've already talked about. We're going to have a hydrocarbon, a CH chemical, plus oxygen gas to support the flame. And we're going to make CO2 gas plus H2O gas, carbon dioxide and steam. We're only going to do hydrocarbon combustion, so we're not going to burn anything else in this class. We're just going to look at combustion reactions with hydrocarbons, like our fossil fuels. So we need to know these 3 reactions. So here we go. I have 3 reactions for you. What type are they? Hit pause. All right, the first one, 2 molecules of H3PO4 becomes 3H2 gas plus 2P solid plus 4 O2 gas. That broke down. So what is it? Decomposition. Good job. All right, the second one, Mg solid plus S solid makes MgS solid. Magnesium plus sulfur made magnesium sulfide. They joined together. What's that? Combination, right? They combined. They joined together. Combination. Good job. And the last one, CH4 plus 2 oxygens makes CO2 gas plus 2 H2O gas. So we got oxygen to support a flame, fire, combustion. Yes, that's combustion. All right, so we have decomposition, combination, and combustion. So I hope you got those right, and we'll take a break. Catch you in the next video, GCC 107 students.